Okay, we are back. I'm just going to quickly check, make sure everything's working, sound, etc. Okay, we are back. Just going to quickly check, make sure everything's working, sound, etc. Perfect. Perfect. Okay, I'm going to make sure the stream title's correct, and which it is. Perfect. So we are good to go. So I did say 3 PM on the Facebook group. We'll see if we can get people in there. I've got 4 on at the moment, I believe. If there is anyone here that has routed from Facebook, just give me a shout and let me know what you want to see. Just lost a couple more. But we are going to just give it a few minutes to after 3 o'clock. And we'll see if anyone comes in. What I've noticed on that Facebook group, I'm not sure if you're part of it, but there is quite a few people struggling with the helicopters. And what I'll probably do is not fly in London. Let's fly from, where I can fly from. Do you know what? Let's go to one of my favourite airports, Juancho. Sabah. So it's departure, and then we will I don't want to be airborne. Sabah TNCS, and we will start on the gate. So hopefully we are cold and dark, and we're going to fly just across the water to St Bartholomew. Have any of you ever heard of these airports before? Let's just see if there's one going to come on. No, so these airports, if you're ever going to do the short island hops, these are the airports you want to do them. These are so good. Right, so Juancho, I'm going to set it because they can be, let me just make sure I've got it, clear skies. Preset off clear skies, cool, perfect. And we're going to go to the time, 11 o'clock daytime. Okay, so with this stream, I'm going to be mainly, I've had quite a few people already message me asking me to put it onto YouTube afterwards. So even if there's no one on the stream, I'll still carry on with it and put it in afterwards. So these 2 airports, something to note, this one's got a really, really short runway, and this one here has a runway that goes downhill. Well, it's set with a hill on the approach side. You have to be a specially licensed pilot to be able to fly into it. It's fantastic. I flew it in one of the tutorials yesterday, so I've come back to it now. Doesn't really matter for what we're going to do now, where we take off, where we land, whatever. But for reference, this island here is I can't remember. I don't even know how to say it. But anyway, this is Princess Juliana International Airport. You've probably seen the videos of 737 or whatever landing on an airport which the threshold is right in front of a beach with a fence, and people go and stand in front of this fence and they get blown over. That is that beach. That is that airport. It's a really good airport. Okay, so what we're going to do, we're going to have a look at a helicopter, and again, because this is an introduction to helicopters, it's not an introduction into helicopter flying. We will obviously talk about helicopter flying and talk about all that good stuff shortly. However, we're going to talk about how helicopters fly, what they do, how they get in the air, etc. Because if you can understand that, you can understand how to fly them. So let's look at this first of all. So this is the rotor head. So inside here, you've got your engine. We'll take the covers off, and you've got an air intake. So the air intake is what takes the air in. So you've got it up there, you can see it here. Takes the air in by compression, combustion, and exhaust. It will then create thrust. Unlike a conventional engine, for example, like a jet engine, your thrust would usually come out of the exhaust and it would propel you forwards. Okay, so it's a little bit different with a helicopter. What happens is they've got what's called a free power turbine, and this is what is disconnected from the actual engine. The gases from the engine drive into this free power turbine. It's just basically a big compressor wheel. That compressor wheel spins. As that wheel spins, it drives the shaft, which drives the main rotor head, which is here. Okay, so you've got the engine here, and it will be connected through a drive shaft, and then you've got a main rotor gearbox here. I don't think, see if we can get these out so to explain it. You've got your main rotor gearbox in here. Okay, you've got oil tanks here, and then you've got obviously all the internal bits here. Something to be aware of is that these bits here, these elements, are called servo jacks. Now what these servo jacks do is those are what drives a swash plate. So on here, this is a little bit of a different build up to what I'm used to. Bear in mind, I work on large aircraft. You've got a non-rotating swash plate, which is this bottom one, and you can just see the top of the pitch control rod, which is there. And basically what happens as you put an input into the left, your rotor head will move, and it's moved by the swash plate. So the fixed swash plate there, basically, if you can imagine, we want to go left, that pitch control rod will move up. That will move the rotating swash plate, which is this one. That will move that up. That in turn changes the angle of the blades via these control rods here. Okay, so that's the first thing to learn, is that when we are using our cyclic controls, which is the one between our legs, it moves this. When we use the collective lever, that moves all of them. Okay, so that is the big noticeable difference. We've got 3 servos here. So you'll have forward and lateral, you'll have left and right, and you'll have front and rear. Okay, so obviously your left and right ones will give you your left and right, and your front and rear, which gives you forwards and back. Okay, so that's the way to think of it. Okay, you've then got stuff up here, tension links, that's what hold the blades, and you've got your head assembly up here, and that there is just basically a beanie cap. It just sits on the top, and whatever's going on through the head, you might have a slip ring, which is how you can have electrical connectors onto the blades. For example, if you've got blade heating, this obviously a helicopter hasn't. It's a very basic main rotor head. So that's the head spoken about. Now we look at the blades. Now we can tell which way that the blades are gonna turn on this, because your leading edge, your fat end, is on this side, and your trailing edge is on this side. Okay, and that blade will basically turn that way, and that's how we generate lift. If you have a look at a main rotor blade, let me see if I can get into photo mode so I can climb up. The noticeable difference here is if you have a look at that, it's shaped like a wing. Okay, it works exactly the same way as a wing. The air will go over the top and underneath, travels faster underneath, and without going fully into the science, basically it creates a differential in pressure, and the blade will lift and push up. Okay, and then here, we've just seen them from the floor, you've got these elements, and these are called trim tabs, and these are basically for blade balancing. Okay, you have elements in your main rotor head where you could add weights to it. I don't know how detailed these are, but actually this looks pretty good. Yeah, and you've got all these elements, and this is what I really like about this simulator. It's capturing all of these. Stuff to talk about, I mean, this component here, that's called a scissor. You've got a fixed scissor and a rotating scissor, and then obviously you've got your bolts here. Let's have a look just how detailed this is. You've even got, God, that's really sensitive, your clips that hold on your tension link pins and your blade pins. Exactly the same as what you get on the helicopters that I currently work on. Sorry, this is really sensitive. Okay, cool, perfect. Springs in there, they're the dampers. Yeah, it's really quite good. And then there, that little black tube you see there, that's just a static cable. Let's see what we can have a look inside here. See what the details like in here. For the gearboxes and the engines, that's the flying compartment. Where are we here? We need to go up a little bit. Yeah, here's the main rotor gearbox. as you can see in here, and all the components. This is, considering that no one's really ever going to look in here, this is extremely well shown. So you can see there your jacks, those will lift up. You see the gearboxes there, and then you've got stuff like that could be your oil filter just there. These here are going to be your tachos. So that's going to tell you how fast you're going, how fast your rotor blades are going, etc. So it's really well built. Fantastic. Anyway, enough about that. That's not why we've come on the channel. Okay, your next thing to be aware of is your anti-torque. So there's quite a few types of tail rotor blades. These are one of the most conventional ones. Sorry, tail rotor drive systems. These are one of the most conventional ones. Okay, you've got a tail rotor drive system via a tail rotor gearbox, which is inside here. I wonder if we can see it. If we go in, I doubt it. I'm trying to, but it's so sensitive. God, no. So sensitive. But there's a gearbox there. Gearbox has many reasons why we have gearboxes: change the angle of drive, to change speeds, to mount the tail rotor on, etc., etc. Okay, and then you've got your tail rotor blades. Okay, and again, shaped exactly like a main rotor blade. You can see here, fat end, thin end, because they also need to generate lift. Although it's not lift in how we think about it, it's going to be thrust. Okay, now the whole purpose of a tail rotor blade is, if you can imagine that this item here is spinning around at a stupid amount of revs, okay, it's going to want to spin the helicopter, the body of the helicopter, in the opposite direction. You've probably seen all those videos where you've had Black Hawk Down being a good example. You lose tail rotor control, the tail gets blown up, and the helicopter spins out of control. Okay, that would happen when we don't have a tail rotor. Okay, so what that does, that opposes torque reaction. Okay, so torque reaction is that effect that I've just spoken about, and that will just blow the aircraft, the tail, in the opposite direction, keeping it straight. Okay, so really, really basic stuff. And then you've got this here, which is called a stabilizer. So again, look at the shape of it. What do we think it does? You're absolutely right. It's a wing. Okay, now what that does is, when we are in forward flight, to save the tail basically going over the top of the helicopter or below the helicopter, this keeps it stable. This generates lift, keeps that helicopter tail up. Okay, and then we've got various elements. You've got lights, you've got drive shaft covers in here. I wonder if we can see the drive shafts. Be interesting if we can. No, so there's no drive shafts. I don't know how this operates. But in a real world helicopter, you're going to have a big, long series of tubes that go up to your main rotor gearbox and take a pick off from it. Okay, right. That is the helicopter itself. The only other thing we've not really mentioned are the skids. Okay, just, you've got skids or you've got wheels. It's just an alternative. Okay, yeah, and then obviously you've got all your antennas fitted around as well. So use VHF, HF, and all those different frequency bands. Other thing to mention that we've got here is our pitot tubes and our static vents. Okay, and static tubes. What they do is, that's what gives us our forward airspeed, our rate of climb and descent, and our altitude. Okay, altitude being barometric altitude. Barometric altitude is basically using air pressure. Okay, you also have radar altitude. This aircraft isn't fitted with it, which is basically a radio system. You've got a transmitter or a transmitter receiver that sits somewhere in the aircraft. And I mean, I've worked on aircraft where it's at the back, I've worked on aircraft where it's at the front, but it's just basically a radar system that pings a radar signal to the ground. And how you track radar or height above ground is, you take the time taken it takes to get to the floor, because that speed is constant, and back, and you half it, and then it works out your height. And then we have the rescue hoist, obviously hydraulically operated rescue hoist. That boom will come out, and this legend in the back here will go and save someone. And obviously, because you want tea and stickies and no one to believe you, they are filming it as well. Perfect. Let's get our camera mode. That's enough of me talking about the exterior side of it and what everything does. But yeah, it's really important that we understand it. Right on. Thank you very much. See you again. And we'll get in. Okay, so from here, a lot of people struggle with setting up the helicopter.